Our universe is a vast and mysterious place. It's filled with billions of galaxies, each teeming with stars, planets, and maybe even life. But have you ever stopped to wonder where it all came from? The answer, many scientists believe, lies in an event called the Big Bang. Imagine a time about 13.8 billion years ago. The universe was compressed into an incredibly tiny, hot, and dense point. This point, smaller than a single atom, contained all the matter and energy that would eventually become everything we see around us. Then, in a sudden and dramatic expansion, the universe was born. As the universe expanded, it cooled, allowing for the formation of particles, atoms, stars, and eventually galaxies, planets, and even us.
Long before the Big Bang Theory, humans looked up at the night sky and wondered about its origins. Ancient civilizations created myths and legends to explain the cosmos, often attributing its creation to powerful gods or supernatural forces. While these stories are fascinating from a cultural perspective, they lacked the scientific rigor to truly unravel the universe's mysteries. However, even in ancient Greece, philosophers began to explore the universe's origins through observation and reason. One such thinker was Immanuel Kant, who in the 18th century proposed the gaseous hypothesis. Kant envisioned the solar system forming from a rotating cloud of gas and dust, a notion surprisingly close to our modern understanding. Another influential figure was Pierre-Simon Laplace, who, building on Kant's ideas, developed the nebular hypothesis. Laplace suggested that a rotating nebula, or cloud of gas, gradually collapsed under its own gravity, leading to the formation of a central star, our Sun, and a surrounding disk of material that eventually coalesced into planets.
The early 20th century brought about a revolution in our understanding of the universe, thanks in large part to the work of astronomer Edwin Hubble. Using the powerful Hooker telescope at Mount Wilson Observatory in California, Hubble made a series of groundbreaking observations that would forever change our cosmic perspective. At the time, many astronomers believed that the universe was static and unchanging. However, Hubble's observations of distant galaxies revealed something astonishing. They were moving away from us. Not only that, but the farther away a galaxy was, the faster it seemed to be receding. This discovery was a major turning point. It implied that the universe was not static at all, but rather expanding outward in all directions. To visualize this, imagine baking a loaf of raisin bread. As the dough rises, the raisins, representing galaxies, move farther apart from each other. Similarly, as space expands, the galaxies within it are carried along for the ride. Hubble's observations provided the first concrete evidence for an expanding universe, a concept that would become a cornerstone of the Big Bang Theory. If the universe is currently expanding, it stands to reason that it must have been smaller and denser in the past.
Section 4. From Fireball to Galaxies, the universe's incredible journey. The Big Bang wasn't just an explosion of matter into pre-existing space. It was the creation of space and time themselves, a concept that can be difficult to wrap our minds around. In the first fraction of a second after the Big Bang, the universe was an unimaginably hot and dense soup of energy. As it expanded and cooled, this energy began to condense into matter, following Einstein's famous equation E equals mc squared, which states that energy and matter are interchangeable. One of the first particles to form were quarks, the fundamental building blocks of protons and neutrons. As the universe continued to cool, quarks combined to form protons and neutrons, which in turn came together to create the first atomic nuclei, primarily hydrogen and helium. For hundreds of thousands of years, the universe remained a hot, opaque plasma, with light unable to travel freely. However, as the universe continued to expand and cool, electrons combined with atomic nuclei to form neutral atoms, primarily hydrogen. This event, known as recombination, marked a crucial turning point. The universe became transparent, allowing light to travel freely for the first time. Over vast stretches of time, gravity began to exert its influence on the distribution of matter in the universe. Slight variations in density, present from the very beginning, acted as seeds for gravitational collapse. Clouds of hydrogen and helium gas began to clump together, drawn in by their own gravity. As these clouds collapsed, they heated up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in their cores, leading to the birth of the first stars.
Section 5. Echoes of Creation. Listening to the cosmic microwave background. If the Big Bang did occur, we should be able to find some remnant of its energy lingering in the universe today. In fact, we do. It's called the cosmic microwave background, or CMB, and it's one of the most compelling pieces of evidence supporting the Big Bang theory. The CMB is a faint afterglow of the Big Bang, a thermal radiation that permeates all of space. It originated about 380,000 years after the Big Bang, when the universe had cooled enough for neutral atoms to form. Before recombination, the universe was a hot, dense plasma, and light, or photons, were constantly scattered by free electrons. This scattering prevented light from traveling freely, much like how fog obscures our vision. However, once neutral atoms formed, photons were free to travel unimpeded through space. These photons, stretched over billions of years by the expansion of the universe, make up the CMB we observe today. The CMB was first detected accidentally in 1964 by Arno Penzias and Robert Wilson, who were using a large horn antenna to study radio waves. They found a persistent background noise that seemed to come from all directions in the sky. This noise, initially a mystery, turned out to be the faint afterglow of the Big Bang. The discovery of the CMB was a major triumph for the Big Bang theory, providing direct evidence that the universe was once in a hot, dense state, just as the theory predicted.